So welcome to my talk on event with functional domain models. And so the goal of the talk is both to introduce the concept of event sourcing to those who, for whom it's new, and then just talk about an approach that I've been using where I sort of write domain models using a functional style, which is the popular thing to do these days. So that's the talk, a little bit about me. So I actually got my start in programming back in the 80s building Lisp systems. Lisp, of course, being one of those early functional and then object-oriented languages, kind of a hybrid, somewhat analogous to Scala in a way. And then obviously, I ended up programming in Java for a number of years. Back in 2006, I wrote the book Pojos in Action, which was all about how to build apps in Spring and Hibernate, which back then were revolutionizing enterprise development. And then I started tinkering around with this obscure service known as Amazon's Elastic Compute Cloud back in 2007, which I think many of you have now heard about. And that work evolved into Cloud Foundry, which was a PaaS that then got acquired by SpringSource just before SpringSource was acquired by VMware. And I ended up spending 4.5 years at SpringSource VMware Pivotal, doing various things. And now I do consulting and training around microservices. So please contact me if you're looking for help. And I'm also the founder of a startup that's building a platform that's going to make it easy for application developers to write event-driven microservices. And I'm looking for people to kick the tires on the platform, so go check out the sign-up URL. And you can find out more information about me at these links. So GitHub, I've got a couple of different examples of microservice applications. I also have microservices.io, which is a collection of patterns for microservice architectures, and my blog and Twitter and so on. So please reach out. So here's the agenda. First, kind of provide the motivation for event sourcing and explain what event sourcing is, and then dive into the details of designing apps using a functional event sourcing approach. All right, so let's get started. So, I'm sure everybody's familiar with the typical enterprise app that's just one big monolith, right? And on the one hand, it's not bad. It's just simple, right? To build apps that work this way, having a monolithic database is extremely simple, gives you nice ACID transactions and all of that. So it's kind of good, right? But if you're building an app that's just, constantly growing, sooner or later you're going to end up in monolithic hell, right? Where you're just going to have this monstrous app that's difficult to understand, deploy, maintain, test, all of those bad things. And I think many of us have worked on those million-line apps that are just hell to do anything with. And of course, the right approach these days is to adopt the microservice architecture, break up your application into lots of little lots of services, some of which may be little, some of which may be large, but just meaningful chunks of functionality that can be developed and deployed and scaled independently of one another. And then at the same time, you break apart your database as well. Each service has its own database. And then to make things even more complicated, maybe you're going to use a polyglot persistence architecture where you'll use a mix of both SQL and NoSQL databases. And some of those databases can be sharded as well. So we've gone from a monolithic app, monolithic database, to lots of services, lots of databases. And unsurprisingly, that results in what you could call distributed data management problems. And it really stems from the fact that we're using non-transactional databases and many of them, right? And so one classic problem is kind of sort of typified by this. So imagine you've got just orders, and orders belong to a customer, right? Incredibly simple domain model. But then let's imagine that there's a constraint where the sum of the totals of the open orders for a given customer must not exceed the credit limit. In a standard relational database, you can enforce that constraint just by using transactions, right? You begin a transaction, you check the credit, you create the order, you commit the transactions, and kind of sort of the properties of serializable transactions will enforce that will ensure that that constraint is observed. But then you go and break it up into microservices where you have order management, customer management. How on earth do you enforce that invariant in this architecture, right? We can't use two-phase commit. That's just sort of totally out of fashion these days. And you even have that within a single NoSQL database where you don't have proper ACID transactions and you can only update a single entity atomically. So you couldn't even, if you put orders and customers in the same database, that NoSQL database, enforcing that constraint is a challenge as well. So what can you do about it? Well, the standard approach today is to use an event-driven architecture, right? And the way that works is you change one thing in one database at a time. And when you do that, you publish an event to say, I've changed it. Another service can consume that event and update its own state and publish more events. And so you end up with this eventually consistent event-driven workflow. So for the order placement scenario, you create an order for a certain amount of money that publishes an event, an order-created event, which gets consumed by customer management, which reserves that credit, publishes an event to say that the credit was reserved, which gets consumed by the order, which can then become accepted or open. And then that could send an email to the user, your order has been accepted, etc. And if the credit check failed, a different event would be published, and then order management could cancel the order and send a notification back to the user. So that's sort of the standard event-driven approach. But then that actually leads to another problem. How do you atomically update the database and publish events without using two-phase commit? Because we're trying to avoid that, right? And the solution there is to just don't update the database. Just publish events. And that's what leads us to event sourcing, which is a very event-centric way of writing your domain model and also persisting the state of your business object, business entities. So the big idea there with event sourcing is that for each aggregate, to use domain-driven design terminology, or business entity, you identify domain events. And those events signify both state changes and also just things that have happened that are notable, like the credit check, the credit was reserved, which is a state change, or the credit check failed, which is kind of a notable event but doesn't imply a state change. And you actually define explicit event classes as part of your domain model. So for an account, it would be the account was opened, it was credited, it was debited. For a shopping cart, it would be the item was added and removed, and the order was placed. So you have these events. And then where it gets interesting is, rather than persist the current state of an entity, standard account table with a balance, you actually persist the events instead. And then to actually reconstruct the current state of an aggregate, you load those events from the database and replay them to to reconstitute the current state of the entity. And then if you actually have a large number of events, you can periodically snapshot to avoid having to replay everything from the beginning of time. And what's kind of interesting there is that if reconstructing the current state in functional terms is doing a fold over all of those events, so you can sort of think of the present as a fold over history, which is kind of a nice encapsulation of the idea. And then the other part of it is aggregates are these entities that commands flow into. Commands represent requests from the outside world, and events representing both state changes and things of note flow out the other side. And the way this would work in a particular application is that a request comes in to update a particular entity. You load those events from the database. You instantiate, say using the default constructor, a blank entity, and then you replay the events. You sort of do the fold at that point to reconstitute its current state. You process the command, which yields new events, which then get persisted in the event store. And then you can have subscribers. Oh, and you're also doing an optimistic locking check as well. And then you can, on the other side, you can have subscribers to those events, which then get notified when those events have been saved, and they themselves can update new aggregates, update CQRS views, and also send out notifications to the user, emails, text messages, and the like. So that's sort of the big idea behind event sourcing and how you would use it in your application. So a bunch of benefits to doing things this way. It solves a whole bunch of challenging data consistency issues in a microservice and also NoSQL architecture. It also gives you this nice, reliable way of publishing events, right? Because state changes correspond to events, and you can't have one without the other. And so you get, you get a guaranteed, reliable stream of events out of your system, which could drive predictive analytics, feed into Spark streaming, for example, but also just send out emails. Your order has been received, etc. It also solves the OR mapping problem because you're serializing events, not your domain objects, and the structure of events typically is quite simple. And you can just say serialize to JSON, for example. And also, this model is reifying state changes. So you've actually got an explicit sort of representation of the state changes of a given business object. So that actually provides a reliable audit log. So you can always go back and see what has changed by whom to a given business object. And you could even just display the history on the screen. Like I recently started using Asana, right? And you look at a task in Asana and you see the history of that task, who created it, updated it, and so on. You get that kind of behavior for free with this model. And what's really interesting, it also gives you the ability to do temporal queries as well. You can look back in time and see what was the state of a given entity 3 days ago, for example, which is really useful in some heavily regulated domains like finance. And also, it actually, because it's preserving the history of everything that has happened within the system, you could actually implement a new feature today, but then replay through that module all of the past events, and it's sort of behaving as if you had implemented that feature in the past, which is kind of an intriguing idea. Okay, bunch of drawbacks, right? It's kind of the model itself is different, so it's sort of weird and unfamiliar, and there's a sort of period of getting used to it. Events, once they're published, do not go away. You can't effectively kind of apply schema migrations. So you could sort of dynamically on the fly, but the events never go away. So they could, in theory, if you have a badly designed event, you might actually have to deal with that for eternity, which can be a problem. Because this is a message-based system, there's the possibility of duplicate event delivery, right? So you have to design event handlers to be idempotent. So that can be a challenge. Because you don't have ACID in this model, applications have to be designed to deal with eventually consistent data. So, for example, an application could update some entity and then then query a view to retrieve that entity, and that view might not have been updated yet. So, you might have to sort of carefully design your UI, like make the assumption that that update had happened, and then later fetch the data, for example. And then also the event store itself only supports primary key-based lookup of the entity's events. So if you need to do queries, which involve joins and filtering and that kind of thing, you have to use command query responsibility segregation and implement separate views that are maintained by folding over the event stream. So it's another sort of complication there, but it means that you end up with a bunch of views that are heavily optimized towards the queries that they need to support. So you end up with quite a nice scalable performance system. So it's probably something you'd need to do anyway. So yeah, so it's both good and bad, but it's something that I've found that has worked quite well in practice. Oh, yeah, sure, quick one.
Would you need your messaging substrate to be reliable for this, or would we have to rely on retries?
Oh, that's a really interesting question. So, yeah, so does the messaging system need to be reliable? I guess the short answer is yes, it needs to be reliable, give you at least once delivery semantics, and also preserve ordering as well. But that's sort of the kind of functionality that gets built that the event store itself provides. Or, so if I'm building an event store, I'm making sure that it provides those guarantees, and if you build one yourself, you should build in those guarantees as well. Good question. All right. Okay, so that's quick intro to event sourcing. Kind of want to talk about, well, okay, so how do we use this to design business logic? How do we design domain models? So what I found actually in a lot of the microservices and event sourcing work I've been doing, domain-driven design is really kind of a good guideline. So go read the blue book, go read the red book, right, implementing DDD. So you kind of want to use all of the standard building blocks of domain-driven design, entities and value objects, services and repositories. And lastly, aggregates, which are kind of pretty much, which is sort of something in the past I kind of really didn't embrace. I just kind of did OO that was sort of DDD flavored. But I think when you're using event sourcing and just in particular and designing microservices in general, you kind of want to think about designing aggregates very explicitly in your work. So I'm going to talk about what aggregates are briefly. So the big idea, right, is you've got your domain model, it's a bunch of classes, entities, value objects, and you really want to partition it out into aggregates. So it might be a little hard to see, but an order becomes an aggregate. A customer is another aggregate. A product is the third aggregate. And they end up, so you're sort of chunking your domain model into these little clusters of objects, which actually have fairly loose connections between them. So your domain model is no longer this tangled mesh of objects. It's sort of comprised of aggregates that have very constrained relationships between them. And so an aggregate, right, is a graph consisting of a root entity and then other objects, entities or value objects are hanging off it. And they tend to correspond to business objects like orders or customers and products and shopping cart. But there's sort of constraints, right? So a reference to other aggregates, to other aggregate roots, is not by a direct object reference as we would normally do in a traditional OO model, but instead it's by the primary key. So, for example, an order line item does not actually have a reference, an object reference to a product, but it just has the product ID. So, which takes a little bit of getting used to, but it actually breaks this tight coupling and it's just sort of like almost like a foreign key reference. And then it gets a little more interesting. So the actual order line item could contain a copy of the product's name and the product's price, which on the one hand sort of is like, well, that's kind of like denormalized and violates normal form and all of that, and sort of, but on the other hand, it actually sort of makes sense from a business perspective of, well, when I place an order, that order happened at a particular point in time, and the price of that product was, you kind of want to capture what the price of that product was at that particular point in time. So it's, from a business point of view, it actually makes some sense. So you've chunked up your domain model into aggregates, and there's just these ID-based references to other aggregate roots. So that's broken it apart, made it a lot more modular, which from a microservice point of view gives you a choice of very flexible deployment. You could actually put customers and orders in the same service, or you could break them apart and deploy them separately. So that's kind of a nice added benefit. And it's also important to think hard about the boundaries of each of your aggregates, because one transaction is the update of a single aggregate. And so you don't actually have the opportunity to update multiple aggregates within a single transaction. And if you think about, well, if I was using Mongo or Cassandra, let's just stick with Mongo, right? You know, these aggregates map very nicely to a Mongo document, and Mongo only lets you update one document at a time, you know, atomically, right? And so it's sort of surfacing that constraint back up to the sort of the design of your domain models. And so it's forcing you to think of that constraint explicitly at design time. And then also you think, well, in a relational database, I can update many things, but once you start scaling out and you're sharding, for example, having this constraint of only updating one thing at a time actually makes sense as well. Otherwise, you end up with the need for distributed transactions. So anyway, so you kind of have to think explicitly about this, and then, you know, design your granularity correctly. So, and you have choices, right? Like you could, I mean, I talked with some folks once who basically, I think, made their entire system a single aggregate, right? And that was kind of good in a way, because it meant that their model was always, updates were serialized, and so everything was guaranteed to be consistent. But you probably don't want to do that. You know, you probably want to adopt a more fine-grained approach, so customers and products and orders would be their separate aggregates. And it ends up being a trade-off between, on the one hand, you have great consistency if you have a single aggregate, but on the other hand, you're giving up on the ability to decompose your system into services. It's not going to scale because every update in your system has to be serialized through this one aggregate, and the user experience is going to suck as well, right? So you kind of have to find the right balance in the system. Another part of this, of course, is domain events, right? You know, so those represent notable occurrences within the system, and also records the state. It's part of the public domain of the API, or sort of the public API of your domain model. So you kind of have to think carefully about the design of them. They're going to have metadata like the ID. They're going to have essential attributes that are required in order to process that event by the aggregate. So the aggregate needs certain pieces of data in the event in order for the business logic to make sense. But then there's a concept of domain event enrichment, where you add extra attributes that are not needed by the aggregate, but they're used by consumers of the event. So you actually eliminate the need for a consumer to go fetch that data when it receives the event. So you can start stuffing extra things, carefully. You don't want to overdo it. You also have to think about the design of the commands, right? So these are created, they capture the data that's coming from the request. They're processed by the aggregate to yield events, and they just tend to be immutable. They're just collections of value objects, right? And so it's just data that's needed to validate the request, create events, do auditing, and that kind of thing. So at the bottom, if you can see that, there's an example of some commands. Okay, so there's sort of first kind of piece of code I want to show you. It's just sort of a hybrid OO approach that I started off with. And that just mixes state and behavior into the same class in a very sort of traditional OO state. So a customer has like a credit limit field, as well as a map of credit reservations, plus the actual behavior for processing commands and applying events. So classic sort of OO with a bit of FP thrown in. So there's some base traits that these aggregates have to implement. So there's an aggregate trait that's parameterized by T, and that has an apply event method that's a pastoral function from the event to T. So that kind of captures the idea of updating state in an immutable fashion by applying an event. And then there's a command processing aggregate that has a process command method that gives you a partial function from a command to a sequence of events. So those two things sort of capture the essence of what an aggregate is. And then you look at the code, it's fairly straightforward, right? So a customer aggregate is a case class. There's some available credit, reserved credit methods for doing basic computation. Process command does pattern matching against the command with a little bit of business logic to check to make sure you're not exceeding the available credit. And it just returns events, or sequence of events. And then on the applying event side, apply event is is doing pattern matching against the event, and just using the copy method to actually return an updated copy of this immutable case class. So, there's not a whole lot of business logic in here, but I think you get the idea. And the actual underlying event store API, it's funny, it's easier to read on that one than this one. It's got basic save, update, find, and then at the bottom, subscribe methods. And it's all parameterized by T that's constrained to be a subtype of an aggregate. So, in a way that's kind of good, right? But if you kind of dug into it, there's a whole bunch of unsatisfying things. Like it's throwing exceptions, right? Which is not very functional. The actual typing in terms of the events that in the signature, it was event rather than the events that this particular aggregate knows how to produce and consume. And, and also this is a sort of FP conference, right? And sort of OO is a bad thing, right? Well, actually, I kind of like OO, but it's, it's not that functional. So where it got interesting is I belong to the Oakland Scala study group, and we get together once or twice a month. And recently we've been studying Haskell, which has made a whole bunch of us extremely happy. Intriguing language. I still don't understand what I'm doing half the time. But part of what, one of the things I did, I stumbled across this Haskell type class for event sourcing. And it's just sort of incredibly simple and elegant, right? So it says, a type S is an aggregate if it has these methods, or so if it has these operations. Execute, which is takes an aggregate and a command and gives you back either an error and an event. And then apply takes the aggregate and an event and gives you back an updated aggregate. And then there's seed that creates a blank one. But where it gets also super interesting is that the types of the errors, the commands, and the events are actually defined abstractly at this level. These are kind of analogous to abstract type members in a trait. And this is part of a Haskell extension known as type families. And I just thought that was just nice, right? It's just elegant. Lets you write code like this, which is actually doing a fold over events to reconstitute the current state. So it's calling apply to apply an event and seed to create the initial state. And I've actually been building on this, implementing a tic-tac-toe game as a web service that's actually using a REST, invoking the event store's REST API. So here's and I took the tic-tac-toe game found it on a web page somewhere, and I've sort of layered an aggregate on top of it. So you can see that it's defining the concrete types for error, an event, and command. It's also defining what executing a command means, and it's just actually trying to make a move, like place a 0 or X, or O or X at a particular square, and if it succeeds, it returns the move made event, otherwise it returns an error. And then at the bottom there's the apply event logic. That was just kind of a quite nice definition. But along the way, actually working at this level was quite straightforward, but then I had to deal with advanced concepts like in Haskell, like getting the value of an environment variable containing the URL to the server. right? I mean, that was like, felt a huge sense of accomplishment when I did that, right? And then I made a REST call. That was awesome as well. So this level was easy. It was sort of dealing with the outside world got harder. Okay, so that made me think, let's just save questions to the end. That made me think that, well, I could do better in Scala, right? And then I came across this paper that was talking about how you can implement type classes in Scala. And in particular, it had a section about how you can represent those type members, sort of the associated types as abstract type members. And that sort of inspired me to just do it better. And so here's the new model, right, where I've got a functional separation, sort of function of state and behavior. So I have a customer data type that's just pure state, and then there's a customer aggregate that's sort of a type class instance that's got all of the behavior. So there's a couple of traits that define, or couple of type classes that sort of capture this behavior, right? So we've got the aggregate type class that's got the new instance behavior corresponding to the seed, and also the apply event logic as well, and that's used by the event store to reconstitute the state of an aggregate when it's loaded from the database. So we've got that bit, and it's got an abstract type member that's the aggregate event that's currently constrained to be a subtype of event. Though that might not be necessary. And then there's the command processing type class that represents the concept of processing commands, and that's got an abstract member, type member, representing the type of the command. And unlike the Haskell version, I've hardwired in a try, so I just didn't want to go down the route of adding complexity of making that extensible. But yeah, that would be a pull request if anyone's interested. So here's the customer, behavior, customer sort of class, right? Case class, it knows about credit limits and credit reservations. There's a bunch of functions that act on it. Reserve credit, returns a failure if you try and exceed the credit limit. So that seems pretty reasonable. And then here is the actual concrete type class object. So it's defining the actual types of the command and event. So it's a customer command and a customer event. New instance is actually just creating a blank customer. And then process command is sort of doing the obvious thing, pattern matching against the command and returning the appropriate event. And in the case of reserving credit, it actually tries to reserve the credit. If it succeeds, it actually forgets about the updated customer and just returns the event. And if it fails because the credit limit was exceeded, it returns the credit limit exceeded event. So pretty straightforward. And I think some of this could be abstracted away. And then apply event's pretty simple, right? It's just all the actual business logic to do it already exists. So it's just calling reserve event that's returning a try and then just getting the value out of it, because we know that will succeed at this by the time we get to this stage. I've also been experimenting with using lenses as well. That was just for fun, really. So apply event is defined to call this modifier modify a function that's actually gives you a partial function from an event that then when you give it to a function that when you give it the aggregate will return the updated aggregate. So it's sort of kind of a couple of different levels of function there. But then that lets you use like lens code to implement apply event. And so this is using the Monocle library, and so you can just implement all this functionality using modify or set, and that was kind of interesting. If you like that kind of thing. And then the event store interface is actually a bit simpler. It's all parameterized by the type of the aggregate, just with a constraint to say this must be an aggregate. So it's quite nice. I feel kind of an improvement over the hybrid version. So a couple minutes remaining, just kind of wanted to look at a bigger picture of design, right? So if you actually look at a microservice, it hosts one or more different types of aggregates. There are these various adapters that are consuming requests from the outside world and also events from the event store. And then invoking in one case a service, and in another case an event handler, which actually then figures out an aggregate to send the command to, and then that command will actually result in events that get persisted in the event store. So if we consider the actual place order story, right? So as a customer, I want to place an order. And then you can think of a scenario that's got various preconditions and postconditions. So the old school way of doing this, of course, was to begin a transaction, reserve the credit, create the order, commit the transaction, right? But in this new world, this ends up being an eventually consistent event-driven workflow. So the service, when it gets a request, in this case, to create an order, it actually has to create what's called a saga, which is a little state machine that coordinates the process of kind of approving the order, right? You can imagine in a more complicated scenario, not only do you have to check credit, but you also have to reserve inventory as well, and do 5 other things, right? So there's this whole kind of workflow that has to happen before the order can be properly accepted. And in some scenarios, you would create a synthetic saga, but in this case, they're actually using the order as its own saga, so it's coordinating its own approval, right? It's publishing the events and then gathering the events back, well, in this case, just from the customer, but it could also come back from the inventory service as well. So the create order service, method creates an order, which then publishes an event, which then gets notified the credit's been approved, and then it can say I've been approved, right? So that's the big picture flow. But then you also have to think about compensating transactions, right? Whenever you have eventual consistency, something when it's time to actually perform a step, the preconditions for that step might actually be false now, right? So the credit check might fail, so you have to cancel the order. The credit check might succeed, but by the time, and then you tell the order that, but the customer might have already canceled the order, so you have to undo that credit reservation. And so and actually you have to think quite carefully about all of these compensating transactions. But in this case, it's fairly simple. So yeah, creating an order, here's what the code looks like. And it's actually implemented in terms of this DSL that's just sort of saying, well, we're creating an order aggregate and we're sending it a create order command, right? And under the covers, it's actually instantiating the aggregate object, processing the commands, applying the events, and then persisting them in the event store. So it's actually picking up this implicit event store under the covers and using it. So that's quite nice. And then, so that's resulting in an order created event being persisted in the event store and then being published. And here's the event handler for it. So we're creating a durable name subscription to the event store. So if the consumer is not actually up and running, it's going to get the events when it starts up again. And then here's an event handler for order created that's saying, well, I'm going to update this customer aggregate with this particular ID. So it's the customer attribute of the event. And I want to reserve credit for the entity the order entity that published the event for this amount of money, the total coming out of the event. And that under the covers, that's actually loading the customer aggregate with that ID, processing the command, applying the events to the aggregate, and persisting it in the event store. So the nice thing about Scala is that it lets you write all of this in a fairly concise style, which I really appreciated. Anyway, so I'm out of time, and fortunately I'm out of my slides as well. So I hope that you found this useful, and I'd love to get feedback. So shoot me an email about suggestions on how to improve this talk or what you thought about it, etc. So in summary, right, event sourcing solves a variety of problems with modern microservice NoSQL application architectures. You get a nice flexibility in terms of how you deploy your app, whether it's monolith or microservices. You can defer making that choice. And then Scala is a great language for implementing all of this stuff, right? Case classes, pattern matching, the fact that current state is a fold over events, implicits and type classes, and so on. But I will say that Haskell is super intriguing, and I would encourage everybody to bang their heads against the wall and try and learn it. Anyway, so thank you. Here's my contact info. And please, if you're interested, check out my event sourcing platform. So thanks. And I think I might need to...